This has been quite a chapter. We are finally at the last section. It began with waves and particles. We learned about quantum numbers. And now we're doing electron configuration, which I do think many of you learned in high school. Why such a big deal? Because it can teach us about reactivity. You may doubt that today, but I guarantee by the time we finish this course, it's going to give you a feel for how things work. So I put this up because it shows the S's, it shows the P's, it shows the D's, it shows the F's. Why didn't they leave the table that way? It is way too wide. So what they did is they took the F's and they put them underneath, all right? I also have up here a table that has been lifted out of the book, and I strongly encourage you to keep it next to you as you work so you don't spin your wheels, you don't waste time. I encourage you to get a table and label it. I'll use the one I put down here. This is an S1, this is an S2. Recall +1 oxidation state, +2 oxidation state. Where did that come from? Well, if we get rid of those electrons, we end up going to the noble gas configurations, which are found on the right-hand side. That's the cores that we talked about when we write our electron configurations. So I want to kind of teach you a way to quickly write an electron configuration. I'm going to say to you, you should run your finger across the periodic table. I would do this if we were in person, but instead I have to use my Apple Pencil. I chose silicon. And here silicon sits on the periodic table. So what I do first is I find the core. I look for the noble gas in the row above, and it happens to be neon. And then I will go to the left-hand side and rub my Apple Pencil across. I will first come to a 3s2, totally full, and then I will come to a 3p2, which is not totally full. So that's my electron configuration, and I will have my S electrons here, and I will have my P electrons here. It is this easy. You do need practice, but I'm telling you, please don't shy away from this. Easy points. What happens is, this is chapter 6, the last chapter before midterm 2. People tend to put off studying, but it's really foolish because you can gain a lot of points in a very easy way. Shouldn't have said that out loud. Okay, there are going to be exceptions, and that's because of closeness in energy of those subshells. Remember we talked about the 3D and the 4S's, how they were kind of close in energy? Well, that's going to come into play here. We're going to talk about filled or half-filled subshells, and it affects both S's and D's. If I want to talk about half-filled, I will have the element chromium. I expect an argon core, and I expect a 4s2 and a 3d4 for my valence. When I put those electrons in, that's not how things are actually going to happen. We find that chromium has only one electron in the 4s, and it has 5 unpaired electrons in the D. That is what has been found by experiment. That's why we call this half-filled. Another example is filled, and that's copper. There is an argon core and a 4s2, 3d9. So there's my 4s2, and now let's make my 3d9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have one lonely unpaired electron. So what we find with copper instead is we find a single electron in the S, and we find a full D shell. I don't want to say these are sometimes questions on midterms, but they are. And note what elements lie below copper, what elements lie below chromium, because they are also going to have the same behavior. Now, we wrap up this chapter, and it's really important that you practice. I trust you, but I want to work some with you here in class. So I took question 76, and I made myself a little place that I can work. So all I need to do is fill things in. Magnesium has a neon core, and it has 3s2. My electrons are totally paired, and I have 0 unpaired electrons. Germanium has an argon core. It is a 4s2, 3d10, 4p2. So if I look at my p, I will see there are 2 unpaired electrons. Granted, you can't do it this fast. I had to work on it before I came to class so I could easily fill them in. If I go now to bromine, it is an argon. It is a 4s2. We traverse the 3d10s, and now we have a 4p5. So let me draw the 5. 1, 2, 3, 4, 5. What's a common oxidation state of bromine? Well, if it is bromine -1, and you can see that if I add an electron, I will get to a noble gas. So really, pieces are going to start to fit together. Things you were forced to memorize, bromine is a -1 in chapter 2. Now that we're doing electron configurations, you can see why that comes about. Both of these examples had 4s2 3d10s. Running your finger, Apple Pencil across, that's how you would come up with the electron configuration. If I go to one you're not as familiar with, vanadium, it's a transition metal. It also has an argon core. It has a 4s2 and it has a 3d3. So what I have here, I'm just going to draw it out. There are my s's. I have my d orbitals, and I have 1, 2, 3. So this has 3 unpaired electrons, all right? Yttrium, again, another very odd one. It has krypton as its core. It is a 5s24d1. It has 1 unpaired electron. And finally, I don't even know what Lu is, but I do know that it has a xenon core. It is a 6s2. Here we're using all those F14s, and I have a 5d1. It is going to have 1 unpaired electron, okay? So questions occur like this on a midterm. They could ask you for the number of unpaired electrons. They could ask you for the electron configuration. Please practice. All right, and that really ends the chapter. It is a lot of, I think in a way, disjointed but jointed information. For someone who has a lot of experience, they're looking at this going, oh, I remember, this is how things fit together. For the beginning student, it's as if you want to rip your hair out and say, none of these things seem related. So focus on wave-particle duality, focus on quantum numbers, focus on electron configuration. We will have practice midterm questions in class. There'll be lots of tools for you to use, but the most important thing you can do is ask questions. By now, we're way into the 6th week of the course. No, we're already into the 8th week of the course. I'm hoping you found a teaching assistant that is able to help you and easily answer your questions. I hope you may have been coming to office hours. I know this is unusual being online, but when we went online in the spring, it was a good office hour. We had, I'll call them the regulars. I have them scattered throughout the 3-day period. Try to attend one of them.